we need to talk about molarity and dilutions. Molarity is a way, just like density is a mass per volume, molarity is a atomic density, and the atoms per volume, or moles over volume. The units, the pluggable variable is given as capital M, but the units are often also given as capital M. But the units of molarity is a mole within a liter. So please note that the units need to be moles and the units need to be liters. But molarity could be a scientific notation. So we could do, no one ever really does it, but you could do a kilomole, which would be 1,000 moles per liter, or 1 mole per milliliter. And you could do a millimolar, which would be like, would be 1 mole over 1,000 liters. You could do, oftentimes we report things as micromolar, which would be like 1 mole per 1,000,000 liters. But for most parts, it'd be best just to keep it as a standard molar unit. But so how do we calculate this? If you're just given moles and volume, you can easily calculate this. But you can rearrange this equation as always. If molarity times volume will give you moles, and you can also put it as molarity, what moles over molarity would give you your volume. But what are we doing? We're simply rearranging the equation. How do we get from here to here? We're multiplying volume by on both sides, so that volume cancels out with volume. How do we get from here to here? We're dividing molarity from both sides to get it to here. So don't take that too harshly. Also, we can go from grams to molarity, and simply that we go from mass to moles to molarity, just the same way as we went from grams of A to grams of B. We can go from grams of A to moles of A to molarity of A. Relatively straightforward. So let's take a problem. What would the molarity be of if I had 82 grams of magnesium chloride dissolved in 750 milliliters? What would the molarity be? So the first step is always going to be getting our moles. So setting this up, 82 grams magnesium chloride. We need to find what is the molarity of magnesium chloride. What is the molar mass? Well, as I said, magnesium is about 24. Chlorine is about 35.5. So we're going to say 2 chlorines puts about 71. So 71 plus 24 is about 95. I'm just rounding to get us closer. Then we have to turn our we're going to divide by our volume, but we have to turn this into liters. Now, I am fully competent to turn milliliters into liters without doing extra steps, but I'm going to go ahead and set this up for you guys, because there's 1,000 milliliters in 1 liter. I can safely just say move the decimal place 3 over. But rather than jump that step and lose someone, I'm going to go ahead and show it out. So 82 divided by 95 divided by 0.75 is going to give us a molarity of 1.2 molar. It's 1.15, but once again, 2 sig figs. I'm going to keep it as 2 sig figs. That is a standard thing. You could also go from molarity back into grams. What if I had 0.85 molar of, we took 25 milliliters of 0.85 molar magnesium chloride. We're going to use the same thing just to save on calculation. So 0.85, got to remember units, moles per liter, so the units make sense. There, in 1 liter, there's 1,000 milliliters, and we're using 25 milliliters. Milliliters, liters. And then we're using our molar mass, 95 grams per 1 mole. Moles. So 0.85 times 0.025 times 95. How many grams would that be distributing? That would be 2.0 grams. 2.0 grams of magnesium chloride. One last thing we can typically do with molarity is go from molarity of A to molarity of B. This is because we often skip this step, but we're going from molarity of A to moles of A, to moles of B, to molarity of B. The same thing way as we went grams of A, moles of B, grams of B. So we often rearrange this as M1 V1 equals M2 V2. The reason this works is because M1 V1 is moles. Now, if a second statement that moles 1 are equal to the moles of 2, and the moles of 2 is going to be equal to M2 V2, we can set these two statements equal. So an equation like HCl plus NaOH, if I know the molarity of one of these guys and the volume of one, I can know the molarity of the other or the volume of the other. But you'll always be given 3 out of these 4 variables. This can be used to calculate a dilution. This could be used to calculate a molarity of a second compound. So we'll go ahead and do that real quick. If in this acid-base equation, if I have 1.8 molar HCl, how much do I need to neutralize let's say 30 mils of 0.5 molar NaOH. So this 30 mils and the 0.5 molar all relate to one situation, M1 and V1, and the 1.8 molar relates to the other situation, our acid, or M2. So I'm setting this up 0.5 times 30 equals 1.8 times our V2. So to isolate this, we are going to divide both sides by 1.8. That will give us our volume. Now, because this is in milliliters, our volume will also be in milliliters. 0.5 times 30 divided by 1.8. How many milliliters do we need? We need about 8.3 milliliters. So all this is the basics that come about by paying careful attention to stoichiometry. Now, see. Now, give one more practice problem just to make sure. If I have a 18.9 molar solution, and I want to make 500 mils of 1 molar. How much of the initial solution would I have to use? How much of the initial solution would I have to dilute? So we have situation 1. We have 1 molar and 500 mils. And situation 2 is 18.9 molar V2. Once again, we're going to divide both sides by our M, and this will give us our volume. But just as easily enough, I could be finding a molarity if I give them a volume. 500 divided by 18.9 would mean I would have to measure out 26 we'll say 5 mils and dilute it. 26.5 mils and dilute it to 500 to get it down to a 1 molar solution. But it's very doable, very doable. This is something I have to calculate every day, something I need to figure out when I'm making the solutions that we use in lab. I need to go figure out, I need enough, 500 mils enough for everyone to use it, but I have this really concentrated stuff. So how much do I have to get in order to make the right concentration for you guys? And that's going to be essentially what we'll have to do.